For this question, we're being asked to use algebra to work out the real solutions for two equations. So I'm going to start with the first one, part I. 16a squared equals 2 root a. I'm going to rewrite root a as a to the power of a half. And you should be familiar with that, but just to remind everyone, I can write root a as a to the power of half. I could write the cube root of a as a to the power of a third. I can write the fourth root of a, so on and so forth. And you should be all familiar with this already. Now I'm going to put all of my a terms to the left hand side and my constants to the right hand side. So as I've got 16 times a squared, the inverse of times by 16 is divided by 16. So I'm going to divide both sides by 16 and end up with a squared 2 over 16 is equal to a to the power of half. And now I'm going to divide both sides by a to the power of half, and you end up with a squared all divided by a to the power of half is equal to 2 over 16, which I can simplify to 1 over 8. Now this left hand side I'm going to actually do separately for you. That's the same as saying a to the power of 2 divided by a to the power of a half, and that can be written as a to the power of 2 minus a half, and this is using indices, rules of indices. This exponent now is 2 minus a half. I'm going to use a different color pen because this is something that should be very, very simple. However, many students make mistakes. I'm going to do it step by step. 2 minus a half is equal to 2 over 1 minus a half. If I want to subtract fractions, I need to have a common denominator, so I can make a common denominator of 2. And this left fraction is going to be, can be rewritten as 4 over 2 minus a half. I'll have a common denominator of 2, take away the numerators, and you end up with 3 over 2. You should be able to do that very, very quickly, but I'm just going through it step by step for you. So this bit now I can rewrite. Let me just write it here for you. So a to the power of 3 over 2, a to the power of 3 over 2 is equal to 1 over 8. So I've gone from this line up to here, and that's my explanation. To solve for a, I'm going to now think of how can I actually get rid of this 3 over 2. And I'm going to use the power rule, because I can say on the left hand side, if I raise this to the power of 2 over 3, I will need to raise 1 over 8 to the power of 2 over 3. And now, using the power rule, if I just write that down for you so that you are able to really understand where I'm taking this from. So if, for example, I've got a to the power of x and I raise it to the power of y, I end up with a to the power of x times by y. So if I times these two fractions together, and let me do that for you as well so you can very, very clearly see what's happening. So that's 3 over 2 times by 2 over 3. Hopefully you'll appreciate that this is just going to be 1. Okay, that's just 1. So I've got a is equal to, or a to the power of 1 is equal to 1 over 8 all to the power of 2/3. And just to finish off, a is equal to 1 to the power of 2/3, which is just 1. Okay, and then 8 to the power of 2/3. And the way I would deal with this is I would deal with the third bit first, which I've done here for you already. So hopefully you're happy with me writing that is the same as saying cube root of 8, okay, all squared. Okay, that's the same thing. And the cube root of 8 is 2, so that's just 2 squared. So finally the answer for a is 1/4. And just to show you this visually, if I draw the graphs of y equals 16a squared and y equals 2 root a, which I've got here lined up for you, you end up with something like this. And the graph you can very clearly intersect when x is equal to a quarter, when in this case a is equal to a quarter. So visually you can see that this definitely is looking correct. Part 2. For part 2, I have b to the power of 4 plus 7b squared minus 18 is equal to 0. What you have to notice here is that this is a hidden quadratic. So if I write ax squared plus bx plus c is equal to 0, that's your general equation for quadratic. I can see, and you should be able to see this as well, that this term here, b squared, if I let x or capital Y equal b squared, then capital Y squared or x squared or b squared all squared is equal to b to the power 4. So hopefully you're able to notice, and generally speaking, if you look at this term and square, you should be able to get a part of the term. The coefficients you can deal with afterwards, but I'm just looking at the unknowns to begin with. So once you've established this is a hidden quadratic, you can then try and rewrite b to the power 4 using b squared. So b squared all squared is indeed b to the power 4, and I'm just using this power rule here, plus 7b squared minus 18 is equal to 0. What I like doing, and what I encourage students to do, is let y equal b squared. And now you can basically rewrite this question as y squared plus 7y minus 18, and this is much more familiar for most students. And from here you can use a calculator to factorize, or you should be able to factorize this one yourself. 7 and 18, so I've got 9 and 2. 9 times 2 is 18. I need a minus 18, so one of these must be a minus. I want plus 7 in the middle, so it looks like that one's going to be a minus, that one's going to be a plus. Capital Y, capital Y. I can double check. 9 times minus 2 is indeed minus 18. 9 minus 2 is 7. So from here I'm going to be using this. A times b is equal to 0. So either this term is equal to 0 or that term is equal to 0, because these are terms which are being multiplied together, and then I can go forward accordingly. So I've got y, either y plus 9 is equal to 0, or y minus 2 is equal to 0, therefore y is equal to minus 9, or y is equal to 2. And as you have seen here, I let y equal b squared, so let's put b squared back in. So b squared is equal to minus 9, or b squared is equal to 2. If I square root a negative, you don't have a solution, you don't have a real solution. So I don't need to worry about this. You can just say that there's no real solutions, because I'm going to be ending up with the square root of a negative number. On the right hand side, I can square root both sides and get b is equal to plus or minus root 2. Therefore b is equal to plus root 2, or b is equal to minus root 2. They are your two real solutions. Graphically, I can draw the graph of my quartic. This is a quartic graph. It looks like a quadratic graph, so that's your quartic graph. I can draw in y equals 0, so that's y equals 0, that bit there, and you can hopefully see that there's one solution there and there's another solution here. So visually this is definitely making sense as well.